Good night, everybody. Good to see everyone out. The presentation I have tonight is entitled Altoona Area Coal Mining and Notable Mining Engineers. I am going to deliver the presentation in two parts. The first part would be industry, that is the development of the industry, how the industry came to be at one of the oldest in Blair County next to iron furnaces and foundries, plus also the mining communities that arose from the mining activities. And we'll also be talking about how the coal is mined and what the miners had to go through in terms of effort to mine coal in these areas. Second part is going to be called legacy, and that is what was the aftermath when the coal companies moved out and the communities, other than Coupon, had basically evaporated. And some of the legacies environmentally and the impact on the community in terms of the water supply in Altoona. So the first topic is part one, industry. While digging a well at Plane 6, Samuel Levin unearthed coal. Supplying the plane engine with fuel, a considerable amount was taken and sold. This from the Geology of Blair County, 1881. While not discovering coal in the area, Levin mined and marketed coal up and down the line of the PA Canal. In fact, the coal seam he found near the Lemon House almost 200 years ago was named after him. Also here at the summit of the Allegheny Mountains was the eastern edge of the Great Bituminous Coal Basin of western Pennsylvania. The 9-mile segment along the Allegheny front, extending from the summit to the Buckhorn, was the Altoona coal field. Here's a map of the geology in terms of the coal geology of the Pennsylvania state map, which shows the anthracite region to the east, which is in pink. That's hard coal country in that part of the state. The main bituminous field, which is southwest Pennsylvania, including Pittsburgh, and reaching up into the northern tier. There's a light mustard-colored area in Clearfield and Cambria County. And finally, a dark orange field where the Altoona field is located, and it's just a little sliver in Blair County. The Altoona field is a semi-bituminous, low-volatile coal. This high-carbon coal was especially valued in coke production for iron furnaces and foundries, and later blast furnaces and steel making. Though small in area, Blair County, by accident of geology, has many coal seams exposed or outcropped along the Allegheny front, all of which have been mined for over 200 years. This is a map, a geologic section of the Allegheny front along the valley between Tanning Run and Glen White Run. It's a 300-foot section that includes several black streaks, and those are coal seams. The top arrow shows a principal coal seam that was mined. That was the Upper Freeport coal, also known as the E seam, also known as the Lemon seam because of its discoverer. The middle arrow is the Lower Kittanning coal, which was extensively mined here and throughout western Pennsylvania. That seam was also known as the Miller seam or the B seam. And finally, the bottom coal, the Mercer coal, was in the Pottsgrove group, which is a coal that was principally mined by surface mining. But these are the coal seams that we're going to be discussing tonight. Here's another section of these coal seams. If we took a section along Mill Run, along the Allegheny front in the valley, along Route 36 going to the Buckhorn. Get this on right. And in this case, there are approximately 7 seams that were identified. And in this particular case, all of these seams were exposed through eons of erosion. It is in these valleys along Tanning Run, Glen White Run, and Sugar Run were mined and opened in dozens of places. In all other regions throughout Pennsylvania, most seams are either buried and only accessible by shafts or slope tunnels or drift mines from the surface. Here's a 1905 map of the Altoona coal fields. And you'll see there are stars next to the primary coal companies and mines that were opened in the mid to early part of the 19th century. It's a very small area, and although many small mines were open, the major properties included the Bennington Field, which is in blue, largely owned by the Cambria Iron and Coal Company that furnished coal to the Johnstown steel mills. Now at this mine, you can see it present day on the way up on New 22 near the Glitzen exit. And if you glance off to the right, there is a cemetery and a curve on the main line known as the Bennington Curve. And it is here that the Bennington complex was located, where there were about 100 coke ovens that were installed, and the area was deep mined from that location. The second is, of course, the Glen White Coal and Lumber Company, one of the earliest operations in the 1850s, and they mined their coal and marketed it as a coke to area foundries and iron furnaces, and also sold as house coal in Altoona. Finally, the Tanning Run field was owned and operated by the Altoona Coal and Coke Company.
Excuse me. What coal was marketed in Altoona?
Well, from the various, they were all marketed in Altoona as house coal.
Oh, house coal.
Right.
That's the word I was looking for.
Yes.
Thank you.
Sure. The Altoona Coal and Coke Company was located near Coupon, which of course is on the Buckhorn area. It had nearby mines and holdings also in Cambria County. All these coals mined multiple seams along the Allegheny front, including the Upper Freeport and Lower Tanning. In fact, from 1880 to 1900, Blair and Cambria County were the leading coke producers in the state.
Wow.
So the next slide is, we're going to talk about how the coal was mined. And basically, like most of the mines that were opened in this country, it was through the room and pillar method. And this is a 1928 map of the Upper Freeport seam, located above Coupon area. It extends largely into Cambria County. And it's an underground mining method where miners create a network of rooms or open spaces by removing coal from a seam, leaving behind pillars of unmined coal to support the roof. It produces a grid-like pattern of rooms and pillars, which is surveyed and mapped to show the progress of the mine. A mined out area is a retreat mining technique where pillars are removed and coal recovered with wooden props to keep the roof intact. The main heading, as denoted on this map, was also served two purposes generally. One was for air distribution and ventilation. The other was for haulage in order to bring the coal out of the mine. Submains are shown to the left and right of the main heading with numbered sections, for instance, section 1 left, section 2 left, and onward. And that was basically to identify where the mining was taking place. And the submains were also numbered in that fashion, left and right of the main heading. This map was surveyed and prepared by the Altoona Coal and Coke Company by Joseph Silliman and Company in 1928, a name you'll be reading about or hearing about shortly. So what was it like, and how did you mine in this particular way of coal mining? At the working faces, which was where the coal was being mined, usually a miner and a helper were assigned a room and were responsible for not only mining, but for gas detection, roof integrity, setting wooden posts, and setting rails for the mine car. The first step in the upper left-hand corner was to undercut the coal by hand for a distance under the coal of about 2 to 3 feet. Now, it looks pretty dangerous what that guy's doing there, but that was the essential part of being able to get a day's work done. Usually there were stopes or small blocks of wood that were put in to support the mine. Generally, the next step was to drill holes into the face of the mine, which is shown on the upper right-hand side, drilled by hand, set black powder in the hole and a fuse, and then blast the coal. Third step was basically loading the coal into the mine cars, and that basically would constitute a day's work. Now, there were miners that took a lot of pride in working that undercut because that was essential in terms of productivity. And a lot of guys these people were called practical miners because of their expertise. And a lot of them resisted mechanical mining in decades ahead because they felt it basically cut them out of the ability to work the coal by hand. Now, what we're seeing here in the upper left-hand corner is a coal seam that's pretty thick, where you could basically stand up in it. And basically in Pennsylvania, where you generally saw that was around Pittsburgh, in the Pittsburgh coal seam. And that seam was anywhere from 8 to 10 feet high, depending where you were. It was located throughout western Pennsylvania, especially in Washington, Fayette, Greene, and Westmoreland County. So you could stand up and mine. Generally here, for instance, there were two seams. The upper Freeport was called the 4-foot seam. And you were working in a mine about this high, right here. So if you're working in the lower Katanning seam, which was 3.5 feet, you're down here. So you're either going to be like this guy that's loading the coal car and is stooped all day long, or if you're in the lower Katanning seam, you're either duck walking, you're either kneeling or crawling. And if you're claustrophobic, it's not a good place to be. Generally, these once the cars were filled, they were hauled to the surface on rail tracks by mules or a trolley train, such as an endless cable lifted to the surface in a shaft. Normally, these operations took an entire day. Before hourly rates were negotiated by the UMW years later, workers were paid by piecework or by the ton. Locally, the coal was mined in this fashion, and in terms of safety, the overriding concern was the roof and the ability to make sure you had a sound roof by soundings and things of that nature. There were a lot of people that worked in the mines who were immigrants that did not understand or speak the language. A lot of people that were new to the mines who, if you're getting paid by the ton, you're probably going to take a shortcut.
What were the scowlings that you just mentioned? Bolts in the roof?
No roof bolts. That wasn't until 100 years later.
What were scowlings? I think you said scowlings.
I'm not certain. It might have been a mispronunciation. In any event, basically stoops. Is that what you're talking about?
What?
Stoops. They're pieces of wood to keep the roof up.
Oh, yeah, that would make sense.
Okay.
I thought they put bolts in the roof.
They did years later.
Okay.
Yes.
Sorry to bother you.
No, that's fine. But basically, they took shortcuts. A lot of them didn't pay attention to the roof. And there's a lot of instances, and particularly in these mines around here, where people were killed by coal falling on top of them. And 60% of all fatalities in the mine were because of roof collapses. So moving on, we were talking about the room and pillar mining methods. There's also this business of removing coal pillars, and this was a very hazardous operation because people, once they reach the limit or the extent or planned limit of the mines, all the room coal was removed. That left about 50% of the coal still available to mine. So what they would do when they would retreat out of the mine, they would set wooden posts and start taking out the pillars. Now, this was a hazardous operation because roof quality and support were critical for worker safety. In deep mines, wooden posts were used in abundance for roof support. Over time, the roofs of the mine works would collapse, either induced by black powder charges or natural decay of wood posts. And there's plenty of instances, especially in this area, where a mined out areas that were near the surface of the ground would cause mine subsidence. And there's some of that if you go and walk around some of the areas on the upper part of the watershed. There are instances of mine subsidence, and this is because of these mined out areas. The other pictures, more often than not, children worked in deep mines for tasks such as mule drivers, operating air door passageways, and doing above ground work, which was picking or cleaning coal in a tipple. By 1885, a law was enacted prohibiting the employment of anyone under 12 in coal mines. In 1905, the state cracked down when minimum age for mine work was raised to 14 years old.
Yes.
Another big factor was air. Mine ventilation was a very important part of mining, regardless of where you were. And it was done for two reasons: keeping fresh air at the mine face and being able to have the air and methane reduced to an extent where it could not be an explosion hazard. So maintaining air originally was done by furnaces next to an air shaft that went up to the surface of the ground. The intent was to draw air in from the surface and have it circulate and come out through a shaft by draft. And that was eliminated when fans were installed, particularly at the top of these air shafts, which are located all over the area. And basically, it got the air closer to the work face, and the ability to make sure it got to the active working face of the mine was a continual operation of closing off old works by doors or brattice cloths that were used to make sure the air was circulated. On the right-hand picture is a guy checking methane with a safety lamp. And this was a common feature in every mine. Usually the person that went in ahead of them on a shift basis was called the fire boss, and he would go in and check for basically methane content using a miner's lamp. So that was important because usually methane in association with coal dust is ignitable and combustible. And although the Altoona mines were not considered gaseous, there still was the potential for explosions based on coal dust and any methane in any density or concentration. So this is a Glen White coal tipple, an old picture where the sorting, cleaning, and loading went on. Most coal companies erected a tipple, and usually the coal was hauled to the surface usually by mules or a small steam engine. The first part was to clean the coal, to remove partings like pyrite, clay, and slate. The second process was to sort and size the coal using mechanical screens, where they were directed into bins, and finally loaded into coal cars. This was a gravity operation. When a unit of coal cars were loaded, they were transferred from the siding to the main railroad junction. If coke operations were active, smaller narrow gauge coal cars transported the coal to the coke ovens, like the Canning Run operation. The interesting part about all of these operations that I talked about of the mines was the proximity to the main line of the railroad. And the main line at Glen White was, of course, the siding that comes out near the top of the horseshoe curve. The same applied for Canning Run on the other side. And Bennington was located just along the main line before the main line entered the Gletzen tunnels. So we're going to talk about coke ovens. And here's an 1878 photo or a depiction of Behi coke oven details at Bennington. And in the 1878 state mining report, this figure was included showing the details of this construction. Ultimately, 100 coke ovens were constructed at this location. At the time, the Altoona coal field was the state's second highest coke producer. Basically, the cross section at the top shows the arched shape of the oven, and at the top was a charging hole where the coal was introduced, and then it was allowed to bake essentially for 24 to 72 hours, quenched, and then pulled out and loaded into an adjacent coal car. Here's a better picture of a beehive oven. It's an isometric drawing of what this envisioned. There were thousands of these built all across western Pennsylvania. Basically, the standard oven was about 10 to 12 feet in diameter, and it was about 8 feet high with a conical roof that basically concentrated the heat. The coal was introduced to the charging hole at the top, and then it was raked even for about a thickness of 2 to 3 feet. The front of the coke oven there in the fore picture was bricked up and essentially ignited and then allowed to bake for 72 hours. There was a small vent hole that was put in the top of the brick oven, which allowed for the air and the airflow out of the operation. In this case, the toxic gas would come up through that vent hole, and the smaller it was, the more concentrated the heat was. Usually got up from anywhere from 1,000 to 1,500 degrees Fahrenheit. So after it baked, the bricks in front of the oven were taken out. Water was introduced to quench it. Once it got cool enough, there was a person that got in there and raked the coal out of the oven where it was hauled away, usually by a wheelbarrow or a mule or horse, to the railroad siding. Now here are charging ovens with coal and raking out the finished product. And in the top photo are the charging cars where the coal was introduced. And generally you can see individuals there at the bottom are raking out the finished product. Now, if it doesn't look like coal, there's a reason for that. These are basically gray colored slabs, more or less, where the coke, the carbon and the coal and the ash have been fused together. All impurities have been removed, any volatile gases. And basically what we got here is a very high thermal product, which is used extensively in the blast furnaces from Johnstown to Pittsburgh. Now this wasn't a very good job. If you can envision standing by an oven like that and having to essentially be responsible for loading this material, it's very hot, and it's also extremely difficult to breathe because of the gases that surrounded these ovens. So here's a typical coke oven battery, and the off gas that was produced from coke ovens near Punxsutawney in the village of Walston. There were 2,000 of these ovens that were operated and maintained by the Rochester and Pittsburgh Coal Company. Supposedly the longest battery of coke ovens in the world at the time. But you can see the gas that just came off these ovens continuously, and the hillsides are basically denuded of vegetation. And they still are to this day. It looks like a moonscape in that area. I've driven through it many times. But that was the consequences of that particular beehive oven design. So here's a good place to stop to introduce a firm and also some individuals that were responsible for many of the Altoona coal field and also western Pennsylvania deep mining coal producers. And the J.S. Silliman Company was established in 1887 and what we believe may be the first consulting engineering firm in the city. This company was active throughout the bituminous coal region during the high tide of deep mining from 1890 to 1930. This firm was introduced by Joseph Silliman and his nephew, Walter Silliman, as principals. They employed surveyors, draftsmen, engineers, and clerical staff, and employed anywhere from 20 to 30 people over a 50-year period. Silliman, although it was primarily a mining engineering firm, also designed railroads, buildings, structures, water supply system, and roads. Silliman specialized especially in valuation reports of deep mines with a keen knowledge of coal geology and lab analysis, mine operations, mineral economics, mine plan layout, labor needs, leases, markets, and productivity, and really worked all over the eastern Appalachian coal fields in Ohio, West Virginia, Kentucky, even into Mexico. Here's a typical mine map that was provided in a 1917 report on mine development in an area near Dysart, Pennsylvania. It was a map showing the outcrop of the coal seams, but the report is very detailed, getting into the requirements and costs needed to develop a mine. So a little bit about some of the persons involved. Joseph Silliman was the person that originally came to Altoona. He was from a family that had settled in Schuylkill County and that was responsible for the opening of the anthracite coal seams in that vicinity. He graduated from the Pottstown Academy and went to work for the B&O Railroad. In 1887, he made his way to Altoona and in that fashion established his own company and quickly became an authority and expert on deep mining. He performed the majority of the writing tasks involved in examining these mines, and he also was very good at assessing the ability of, for instance, the mine superintendent or the foreman in actual running a mine. He was in the mines, he got his feet dirty, but was also extremely knowledgeable and savvy about that coal production part of things. His nephew, Walter Silliman, went to Penn State, graduated with an engineering degree in mining, and joined his company's business in 1899. He also performed these studies and also developed a scientific and systematic plan of mineral land taxation in Cambria County, which had existed in some form, has existed in this form to this day. Nearing retirement in 1941, Silliman was the president of the Cambria Mining Company and later assembled a group of investors willing to buy and operate the Glen White mines during the Depression, but to no avail. An interesting side note, he was also the chief organizer of the war bonds drive in this First World War in Altoona. In the 1920s, he and his wife were active in the Women's International League for Peace and Freedom, which advocated pacifism, though perhaps this was reflecting on his Quaker ancestors. So we're going to talk about safety, and we're going to talk about the hazards involved in working in a mine. And the penultimate disaster in this area happened in Portage at the Sonman coal mine on July 15, 1940. Now, this represented probably the last great disaster of coal mine, deep mine gas explosion in Pennsylvania. And it was called the Sonman Mine Complex, which was operated by the Coppers Coal Company on the same seam of coal that most of the Altoona coal companies were operating in. It was a huge mine, 720 miners employed in 2 shifts. It was located 10 miles west of Altoona and had an annual production of about 850,000 tons. So on July 15th, a methane gas explosion, also known as fire damp, occurred. 8 were killed instantly, the remainder trapped 2 miles from the mine entrance. There were some people in the mine that had not even realized there was an explosion until they noticed the reversal of airflow in the mine. It went from a 180-degree condition in a matter of seconds. They knew there was an explosion. So what happened afterwards was a condition called after damp. And that is where you have carbon monoxide in the air that, if not properly ventilated, will have the effect of asphyxiation. So rescuers, in an attempt to reach the mine, took them 8 hours to do so. It was 2 miles from the entrance of the mine. They couldn't get there because the methane concentrations were so high. And the reason for that was the explosion blew out a lot of the doors and airways that got short-circuited to other parts of the mine. So when they got there, 55 miners were discovered dead by asphyxiation. And it turned out that a lot of these miners left notes on their body. And they were reached at 8:30, and the last note was at 6 o'clock. And many of the notes were very poignant, as you can imagine. But basically, these miners just died very quietly because they were unconscious. But that left 37 widows and 107 children. And you can see, and this is pictures from that time, where the families were gathered around the mine shaft. And I guess the one thing that was a constant that day, there was silence around the mine opening. So one of the reasons I bring this up is because mine safety, at least in the latter part of the 19th century, was pretty bad in terms of miner training. I've read hundreds of accounts of miners that died in the mines, and the state had a very detailed accounting every year of coal production, but most of the book was dedicated to these accidents where people died, including some huge accidents like Solomon Mine. But anyway, the inspectors would get in there and invariably say that it was either an accident that couldn't be helped or it was the fault of the miners. I don't think there was one instance where a coal company was ever felt to be liable for some of these accidents. And of course they were, because everything about mine safety is mine training. And it took a long time in order for that ethic to take over. At the time, it was all about production, making sure they get the coal out of the ground, and if it involved accidents and death, that seemed to be an acceptable trade-off. But again, many of these workers were immigrants, could not speak the language, and they had difficulty understanding, what in essence they needed to do to stay safe. And again, that didn't change until the UMW negotiated hourly wages in lieu of piecemeal compensation for tonnage mined. So the next part is surface mining. And what this shows here is a map of the watershed areas downstream of the Altoona reservoirs. The green area was the Mill Run watershed, where there was some negligible mining that occurred. The next over is the Tanning Run watershed. And the Altoona Coal and Coke Company basically had deep mines in the upper portion of that watershed. But you can see the strip mining that occurred in a period of over 20 years after World War II. And the area there was heavily strip mined. And going over next to Glen White Run watershed, the mines of Glen White Run are noted there, but the strip mines also occurred along some of the boundaries.
What exactly is strip mining?
Well, I'll get into that. Basically, it's above ground mining where you're unearthing the coal. None of these landforms were ever reclaimed and were generally left as is, with spoil piles, pools of mine water, and high walls. The reason for that is the state law did not require it. It basically just indicated that they plant trees or something to that effect. So in the Sugar Run mines, a similar condition existed, and that's along Sugar Run. And that area was extensively deep mined and also strip mined, as shown there by the arrows. Basically, down at the bottom of that watershed on Sugar Run, the city had an intake there where they ran a pipe over to the reservoirs in order to supplement the supply, especially in drought. Well, this water turned so bad after a period of time that it just could not it was not deemed potable. Over 1,000 acres of land were strip mined or surface mined in this manner. About half of that area was from the Cavalier coal operation on Kittanning Run. Now this is a little hard to see. This is a surface mine map, and it's an overview of the Altoona fields in the Loudon Page tract of Kittanning Run. And this was an area that was very extensively surface mined. And what you're seeing are these rounded shapes that seem to conform to the sides of a hill or a mountain, and that they're kind of one on top of the other. And it shows the year-to-year progress of surface mining in these areas. Usually the surface mining were conducted along the edges of hills where deep mining had occurred but had not removed the outcrop of the coal. Upwards of 6 seams were mined here, including the deeper Clarion, Brookville, and Mercer seams. Also mined was a fire clay seam under the Mercer, which was suitable for refractory bricks at a brick factory in Blandburg. At this location, Cavalier Coal mined 1.6 million tons of coal and over 500,000 tons of fire clay. Until 1964, the strip mining was not either backfilled or reclaimed. And at this location, for those who may remember, the Big Murph, which was an area in that location, was created. So what caused all this in terms of surface mining equipment were machines that were necessary to take the overburden off the coal and a means to dig the coal once it was recovered in the pit. And the drag line shown in the top photo was from the Cavalier Coal Company. It was a 165-foot boom, 15 cubic yard bucket, weighed 650 tons. And it could reach a depth of excavation of anywhere from 75 to 80 feet. And had the production capacity of about 2,000 to 3,000 cubic yards per shift. Now this equipment basically was the death knell of Kittanning Run in terms of strip mine, abandoned mine lands, and also acid mine drainage, which we'll be getting into later. So moving along, you had a drag line to take the coal, the overburden off. You also needed a shovel to load the coal onto a truck. That's as simple as it gets. Still happens today, generally. Other surface mining equipment, you see a drill rig working in the upper left-hand corner. They are drilling holes, and you can see the blast pattern by the white dots in on the surface of the shooting area. They drilled about 70 to 80 feet deep and would fill those with dynamite and set them off in a pre-timed charge to blast the rock in order that could be removed by a drag line. In the upper right-hand corner is an example of a tipple, not much different from what we saw with the deep mines. And in the lower part of the picture, the lower part of the frame is a auger mining operation. So this was very common back then when drag lines would reach the depth of the excavation. They'd uncover the coal seam. They'd bring an auger miner subcontractor in with these huge augers that conform to the depth of the coal. And you can see the conveyor belt that's basically removing the mine that's being augered out under the hill. Some of those could go anywhere from 50 to 100 feet into the hillside. So I made a compilation of all the mine records that were available from 1878 up through 2020. And we're showing 3 things here. This is really the tail of the tape when it comes to mining in the Altoona coal fields. And generally, deep mining was the major producer from the advent of the industry up until the Second World War. And you can see there's a lot of erratic shapes in that presentation for good reason. And basically, that had to do with the inherent sensitivity of the coal industry toward the price of coal and the market forces. And anyway, the top production times in the Altoona coal fields were during the First World War and into the 1920s. And for the surface mine, it was the period after the war, a lull period throughout the 70s, and then a resurgence in the 1980s. Erratic coal production, as I said, indicates the high sensitivity of the industry to the labor market, market condition, transportation costs, and the demand and price for coal. Next slide is the employment, total number of miners that were employed over this period. And generally, over a period of from 1880 and 1940, generally there were anywhere from 500 to 600 people that worked in the coal industry. And you'll see in the surface mining era, there were barely 20 to 30 people working. And that goes to show the inherent productivity of surface mining. You know, running a deep mine and staffing a deep mine and providing all the safety requirements was very costly. And their productivity could not compare with a giant drag line that would unearth the overburden and hauling out thousands of tons of coal in a week. And basically during that time, total production was around 25 million tons. If you recall, in deep mine extraction work, only 50% of the coal was really ever recovered, even though they did remove pillars. And there was an estimated $5 million in production before 1878. And we estimated about 43 million tons were mined out during that time frame. Based on an original estimate of 78 million tons, the remaining coal reserves were 35 million. Now, just to say, those are estimated reserves, but not marketable, not possible based on landowners, and not possible by environmental restrictions. So, for all intents and purposes, mining in those fields is over. So that brings an end to part one. And part two is going to talk about the aftermath of the coal industry. And I chose a excerpt from Altoona, Illustrated Altoona of 1896. They're talking about the water in this area. They say the water coming from the mountain streams where contamination is nearly impossible is as pure as any in nature's storehouse and very pleasant to the taste, a very nectar of the gods. Now this fanciful description of the Altoona water supply was from a publication of the Altoona Board of Trade, sort of like the Chamber of Commerce yearly brochure. The reality is that mining pollution of all types in the watershed was a growing concern. This pollution included acid mine drainage, deep mine discharges, sewage contamination, and turbid sediment-laden runoff, all of which were exacerbated by recurring droughts. In a few years, this, quote, growing concern became tangible. The typhoid epidemic, floodwaters choked the reservoirs with debris. Severe pipe corrosion was occurring in Altoona, with rusty water as evidence of that. An extinction of all downstream aquatic life resulting from decades of neglect by mine owners in the state that, quote, regulated the coal industry. Far from nectar of the gods, the source of Altoona's drinking water was more like hemlock to the stream ecosystem. This presentation will examine this legacy. So what we're going to do here is just talk a little bit about acid mine drainage. I'm sure some of you may be familiar with the mechanism there. But basically with acid mine drainage, it's all about air. Meaning during mining, pyrite is exposed to oxygen. Pyrite is iron sulfide, which is included in the partings of the coal. And it exists basically everywhere there's coal being mined. Groundwater seeps into the mine. Oxygen, water, and pyrite react to form sulfuric acid, which is then dissolves the metals from the rocks. It drains out of the mine. Dissolved metals react with oxygen and fall out of solution into the stream, turning a bright yellow color. Animals, aquatic animals and plants are killed by the drainage. So that's it in a nutshell in terms of water that's coming out of the mines, and particularly in the Altoona mines where almost all the headings were through drift mines, where coal is mined up dip. So if there's any water or drainage encountered, it drains out of the mine. In every one of these openings, and there's dozens of them all over that mountain, and all of them are sources of potential mine drainage. So what do abandoned mines look like? Well, basically, these are photos from 54 through 58. There's really much more need to be said here. This was the condition these mines were left in. And we see a bulldozer there trying to backfill some of these areas. But a lot of the contamination got worse because these strip mining went deeper into veins that couldn't be reached by deep mines or weren't economical to mine. And what happened there was they got the seams that were much more acidic in terms of their content, and also the overburden was more acid bearing, like acid rock that happened, for instance, on the State College Skytop Highway. In the lower left-hand corner is the mine drainage coming down from Tanning Run down to the Horseshoe Curve. Some more of these pictures. Again, unreclaimed mines, spool piles, and also mine pools in the bottom of the cut. And believe me, this is a recurring feature, just not in Altoona. It's all over Western PA at the time. So we have what was, I'm sure some of you, of course, are aware of the Glen White Village. And these are pictures of houses that existed at the time, 1922. And the only reason I bring these up is because the next topic is directly related to some of these company towns. So in 1916, an epidemic swept through the city in the summer and fall of 1916. Hundreds were hospitalized and dozens died. So the state health department mobilized and sent dozens of officials to Altoona and used incipient contact tracing methods and reviewed and mapped every single typhoid case and potential infection sources in the city and outside the city. And through their investigations, they found that there could only be one infection route, and that was through the drinking of water. And through the drinking of water, it was through the Altoona reservoirs, which were fed by mountain streams, where there were mining towns that were built alongside the streams at Bennington, Coupon, and Glen White. So a thorough investigation of these properties in these company towns, 455 that housed about 1,800 residents, many with typhoid, found animal pens, stables, pig pens, overflowing vaults and privies, and 361 instances of gross pollution. Now, a lot of this was the fault of the mining companies. They were responsible for the company towns, for proper sanitation, for cleaning these vaults and privies, and not allowing, especially pig pens, to be placed in behind the houses. But during rainstorms, it would run off, go into the streams, come down into the reservoir. So the coal companies were ordered to clean up, and the city was cited for lack of watershed inspection and failing to bypass runoff around the reservoir, and relying on this odd concept that acid mine drainage was a germicide. And that was a commonly accepted opinion, except we're talking about a bacteriological or biological type of infection instead of a chemical, what would we say, counteractive. And the city health officer basically staked his job on the fact that we have nothing to worry about here. We have acid mine drainage, which is a good thing. However, it was later determined that in fact it was the reason. There were more tests done, and the city was ordered to install chlorination for its water supply, which is a permanent disinfection feature ever since. So basically, what we have here is a contamination that fundamentally changed the opinion of a lot of people toward the coal industry, and particularly the coal companies that mined on the watershed, 1916. So the city decided, okay, we're going to take care of this. We're going to build a sewer all the way from the bottom of Lake Altoona up through the impounding dam area, Tanning Point Reservoir, under the Horseshoe Curve, and we're going to run sewer lines all the way up in the Glen White Run and up to Coupon. Thousands and thousands of feet of pipe. And basically the purpose there was to collect all the mine drainage, all the sewage, run it down through a sewer, and dump it below Lake Altoona. So you're basically moving the contamination downstream. But that was supposed to clean up the reservoir and the watershed. However, acid mine drainage is probably one of the worst possible things you can have that impacts materials. So they put in terracotta pipe, and over a period of time they found that the iron and manganese and sulfites that would precipitate when it hit the air, and then it was coming down through a sewer and getting oxidized even more, started to drop out in precipitation. So you had this gooey mess of iron precipitate just fill up these sewer lines, and the city was constantly up there cleaning them out and getting even firms to come in to do that on a contract basis. So that went on for a good 20 years, and finally in the 1940s they just gave up. And they gave up because most of the lines were just beginning to deteriorate badly. So that was another instance where, in an attempt to solve the problem, it wasn't, it didn't pan out, so to speak. But it was a try anyway. So then we're going to move on to another attempt, which was successful, and that was the city acquisition of watershed property on November 7, 1941. That was the Glen White Coal Company's watershed area that they owned of around 1,634 acres, 2.5 square miles. And that was a game changer in terms of the city from then on would not allow any mining in the watershed. And this was very fortunate because in 1945, and after the war, is when the surface mining business took off. And they descended on the watershed with these huge behemoths of drag lines and shovels that they didn't mine over in Glen White, which was a big, if they would have allowed it to happen, it would have looked like Canning Run. Fortunately, it wasn't. Now we're going to introduce another person who was a mining engineer, but also fit the times, and that was John Foreman, who was considered at that time one of the foremost mining engineers in the state. He was a noted authority in the coal industry for mining permits, mine layout, surveying, evaluation studies, leases, you name it. He was born and raised in Bakerton, PA, and served in the Marine Corps during World War II, and later got a degree from Penn State in mining engineering. And he served and had hands-on experience in deep mining and surface mining. He worked as a miner, a mine surveyor, a fire boss, a mine foreman, a superintendent, and a mining engineer. And he was also later the vice president of Gwynn Dobson Foreman, head of the mining engineering department for 30 years.
Wow.
So he seemed like he took the typical track of a, quote, mining engineer. However, the man met the moment because in the mid-60s, the state decided to do something about acid mine drainage, abandoned mine reclamation. It was called Operation Scarlift. It was proposed by the Scranton administration, and it was called Operation Scarlift because it was going to remediate some of the damage of coal mining in Pennsylvania. And it was funded by a $500 million bond issue. So, seeing firsthand the damage of coal mining, Foreman applied his technical knowledge toward land reclamation and AMD abatement, and assumed a leadership role in the nation's first abandoned mine program. He pioneered the remote hydraulic deep mine seal, which was used extensively in the bituminous region. He also did 10 major watershed studies throughout the state and numerous AMD and mine reclamation projects, including deep mine sealing, gas well plugging, surface mine reclamation, and outcrop barrier protection. And deep mine fires, including the Centralia mine, you may remember that name, which was the town that was evacuated because of coal fires and carbon monoxide. So, moving along, just an interesting thing here is that in this hydraulic deep mine seal, he basically proposed to, through the mine opening into the mine, would form bulkheads with this aggregate that was vibrated down a pipe, and then the center was filled with concrete, and then the center perpendicular to the mine opening was grouted, pressure grouted, so it would seal off any leakage or anything of that nature. And that was successful in some cases for low-head mines where you could basically go in and flood the mine. You flood the mine, you can't get any mine drainage because there's no oxygen. And essentially, that worked in some cases it didn't because they didn't have an outcrop that was either breached by coal or some other means. But this was very effective, particularly in Moraine State Park and Lake Arthur, which is over by Pittsburgh. That was a lake formed in the 1960s. And the work that he did in basically sealing those mines that you can see around the perimeter of the water was very effective. And it basically elevated the water quality in that lake to a very high extent. And it's one of the top bass fishing lakes in Pennsylvania. So moving along, more progress is made. Altoona had a drinking water treatment plant in the 1970s. And that was basically to treat the Glen White Run watershed and Katanning Run water. One for potable water to the city. The second was for stream release. And it has been in production since that time, over 50 years. However, the stream release side did not work real well because, again, we're talking about corrosion and grit through the water that basically rendered a lot of these treatment units inactive. So the plant is still basically used as a drinking water plant to this day. Some of the biological or some of the chemical analysis of the water is in the lower part of that table. Again, Katanning Run, pH at 2.9, one of the worst streams in Pennsylvania. The 1980s saw a program by the state to declare unsuitable for mining declarations in order to protect environmental areas and high-quality streams. Several local initiatives by local agencies, including the Mill Run watershed and the Bell's Gap watershed near Bellwood. And in both cases, those watersheds were deemed unsuitable for mining. What really paid off for the city was a new technique. It was called wetland treatment of acid mine drainage. And basically, the goal here is a successive alkalinity producing system or a passive treatment for mine drainage that uses a series of wetland cells to generate alkalinity, followed by a settling basin to remove the precipitated metals. And this has worked. This has worked all over Western PA for flows that are generally compatible with a system like this. In Altoona, the Blair County Conservation District built several of these above the Katanning Run Dam, Katanning Point Dam. And Glen White Run has essentially been cleaned up for the last 20 years. Generally, the pH in that stream is around 6.5 to 7 pH. So this has been a stream that has been restored through a biological process that essentially eliminates acidity and acid mine drainage. And this is just a picture of some of the ponds that were put in along Glen White Run near the coke ovens. And these occasionally need cleaning to take out all the iron precipitate and so forth and doing maintenance. But this is a long-term feature and one that the Altoona Water Authority has agreed to help maintain. So we have a success story on Glen White Run watershed. And the other aspect is the Glen White watershed, Katanning Run watershed purchased by the Water Authority in 2020. And again, this is a major advancement in terms of creating a clean water environment for drinking water, but also the ability to control development on the property and trying to get a cleanup of the acid mine drainage on Katanning Run. Cooney Brothers Coal Company had mined this property since 1980 up through 2010. And DEP allowed them to go back to some of these areas that were previously mined, like the high walls and the ponds and things like that, and got them to go in and re-affect those areas, dig out more coal, and then backfill everything. So there was a lot of backfilling done during that time. But since most of the coal has been exhausted, they sold the property to the Water Authority for what was it, Bill? 1.5 million?
Something like that.
Yeah. So there are now 2,400 acres of watershed ground that are in the possession of the Water Authority. So there is hope someday that the water quality will be restored to Canning Run, so it's part of the water supply for the city. And one tangible aspect was a 2022 deep mine reclamation project in this area called the Big Murph. And in the top picture, you can see this vast area in the background, which was reclaimed, formerly a high wall that extended for about 1,900 feet. And during that time, it was backfilled, and also 190,000 trees were planted by Bryn Mawr College as a carbon credit exercise, and that entire watershed, that entire backfilled area has been restored with trees. So we see a tangible effort by DEP, a $1.6 million project that has resulted in some positive steps forward on land reclamation. So I stood up there when this was completed, and at the top of that bank there, at the very top, you could see up the gap, and there are some really stunning views of that Canning Gap up through that area. So hopefully there will be trails and other things that will expose people to that part of Blair County that has not been accessible before. So I thank you for your attention. A lot to go over in an hour, but in any event, that is some of the history of our area and some of the history that's good in terms of an industry that provided jobs and a way of living to the aftermath, which included the cleanup and having success, even though there were some initial problems at the beginning, that we're beginning to see a real turnaround in the watersheds. Thank you.
Well, that's why it's called Big Murph.